Let's hurry this along. I'm a busy man.
Pip pip cheerio, fish and chips and all that. How about a cup of tea, Governor? Crumpets for your mum.
Are you British?
Don't insult me.
What?
I'm clearly Blubarian.
I don't think Blueberry is a real place.
Hey, I'm the foreign advisor here.
Foreign advisor? Wait, what?
I need to start by explaining to you basic human relationships, also called bonds, using a state-of-the-art, highly secret program called Minecraft.
Isn't that a computer game?
No.
I'm pretty sure it is. Look, they have their own website.
That's clearly a different Minecraft.
Are you...
OMG, do you want to understand foreign politics or not?
Fine, whatever.
Alright, these are different types of bonds. So right here we have an ionic bond. This red block here would be a certain atom, and this blue block down here would be a different type of atom, and they would be having a transfer of this white block here, which is an electron. Now, in an ionic bond, there's a metal and a non-metal, so that would be these two, and this is basically how it works. And they just get transferred just like that. And this one over here, because it lost the electron, would have a positive charge. This one, because it gained the electron, would have a negative charge, and they would be drawn together in a bond. Now over here we have a covalent bond, which is between two non-metals, and how it would work is these would be the same atom, and they would have electrons right in the middle, and it would be nonpolar. But if there was a electronegativity above 0.5, they would be closer over here, and it would be polar, this one being negative, this one being positive. However, if it was over 2.1, then it would look more like this atom stealing the electrons from this one, and it becomes an ionic bond like this one over here. And that is about it.
Interesting. Interesting. But all of that seemed like information on intermolecular bonding. What did it have to do with foreign politics?
Well, human relationships are quite similar to the physics of bonding.
I don't think they are.
No, trust me.
Fine.
The electrons represent slices of pie in the real world. As we all know, it takes 8 slices of pie to make an entire pie. You know, pies with chunks missing just doesn't look right. So, you need to have either 8 slices or 0 slices of pie in order to be accepted in modern society.
I suppose I can agree with you on that point.
So, let's say, for the purpose of this example, that you're Mr. O, and you want to be friends with Mr. SR. Naturally, you have 6 slices of pie, and he has 2. So he would give you his 2 slices of pie, and you would chill out and eat the pie together.
I'm confused.
Obviously, slices of pies are negatively charged. So you getting the pie makes you negatively charged, and Mr. SR losing the pie makes him positively charged, and opposites attract.
The more you talk, the less I understand.
Sometimes you have to share pie for everyone to be happy. Let's say Mr. O wants to be friends with Mr. and Mrs. H. Mr. O and Mr. H would have to share 2 slices of pie, and Mrs. H and Mr. O would have to do the same. That means Mr. O has 4 slices left over. Sometimes, people can even share 4 or 6 slices at the same time.
But then wouldn't Mr. and Mrs. H only have 2 slices each?
The H's are just weird like that.
Well, understood. But what if you had a whole bunch of strange metallic people, each with varying amounts of pie?
If that were the case, then all of the people would share their pie at the same time in a roving
sea of pie!
And they would all be drawn together due to randomly fluctuating polarity.
Whoa!
Now, let's talk about a molecule's shape based on the number of things surrounding the central atom.
What does that have to do with foreign relations?
Everything! I'm simply using chemistry as a metaphor.
Right.
If the central atom has two things, then the molecule will be either linear diatomic or triatomic. If it has three things, then it will be bent 120 or trigonal planar. If it has four things, then it will be tetrahedral 109, pyramidal 107, or bent 104.5. This is all based on the concept that electrons want to be as far away from each other as possible. The symmetrical ones are normally nonpolar, and the non-symmetrical ones are usually polar.
That makes so little sense as a political metaphor.
Oh, and one last thing. On a scale of 0 to 100 for intermolecular force strength, ionic bonds are an 85, metallic bonds are a 65, and covalent bonds are the weakest, unless they're made solely from carbon or from a mix of silicon and other specific elements, in which case they're the strongest bonds of all. Also, with the section of covalent bonds, there are the hydrogen bonds. You know, E.T., phone, home, and dipoles and London forces, depending on the polarity of the molecules.
Are you sure that this has anything to do with politics?
Fine, I'll admit it. This is all for a chemistry test. The end.